Hello everyone, this is Alex Design Man, and in this video I would like to show you how Catia V5 electrical harness design and electrical design work. So I have 3 courses on electrical harness design. In one of them I show how the software works, all the commands in the workbenches described. So those are the 2 electrical harness design workbenches and the 2 electrical design workbenches. And after that we do automotive projects. So my courses are focused on electrical harness design for automotive, and of course it also can be used for other domains. But the reason I did the courses like this is because you need more automotive knowledge than Catia V5 knowledge. So the software, it's not very hard to learn. Learning how to use it to design those automotive projects and the rules and everything, that's the important thing that you have to learn. So right now I'm going to show you a quick idea about how the software works. So in the description of this video it's going to be a link to my Udemy page, and if you scroll and study all the courses you're going to see that I have 3 courses on electrical harness design. And you can also subscribe to the channel because I'm going to add another video explaining how to get my courses, how to get coupon codes, if you can't afford the price, how to contact me. So the only way to contact me is on LinkedIn, and I'm going to show that in a future video. Or if you scroll to the videos, I already made a video showing that, only that it's a little older. So here I have Catia V5. So to be able to understand this, you need to know how Catia V5 works already. This means that to understand electrical design, you need to know part design and assembly design. Without those 2 basic workbenches, you cannot learn any other workbenches in Catia V5. So I call those workbenches basic, and all the others I call them intermediate or advanced depending on the workbench. And first here I'm going to open a new part file. I'm going to call this file connector A. Click OK. So here we have connector A, and I'm going to draw a quick rectangle that is going to represent a connector. In fact, I'm going to make a cylindrical connector. I think it's easier. So in here, let's make the diameter of this, let's say it's 30. Exit this sketch, and I'm going to use the pad to make this longer. Let's see how much longer. Let's make this 80 millimeters. This should be okay. So you need to know part design and assembly design in order to manipulate files, to modify files, and also to draw electrical objects like connectors, supports and other stuff, because sometimes maybe you need to design them yourself. Most of the times you're going to find those already to be downloaded as a step file from the supplier's website, and that's the first thing that you need to check, because the supplier has the perfect 3D model of that connector. And in my courses I show how to go on various international websites, how to actually go on the website of those suppliers and download connectors. So in my course there are a lot of connectors that you can download already from the videos. So this is the connector that we have. Let's give this a color. So let's make this color, and I'm going to click on this face and give it another color. So I'm going to imagine that this is the face that is going to connect, and in fact can position a sketch here and just add smaller circle. So let's make this 4 millimeters, should be okay. Let's make a pad here and make this 30 millimeters. So then from here I can just execute a circular pattern. Okay, so let's say this connector has 4 pins like here, and now I'm just going to hide the planes. I don't want to see them for now, and just save this somewhere in a folder. Save. So now let's make another file, another part file, connector B. This time I'm going to make a rectangle. And I would like to already design the counterpart for this connector. So I'm going to add here right in the middle something that is going to be 30 millimeters, but I would like this to be smaller. So I like this to be, let's say 90, 90, and also this one. In fact, let's make this 70. So this is going to be the counterpart of the connector. Exit this sketch, and I would like to use here multipad. Let's make this one okay. So this one it's 40, connector is 80. Let's make this thicker. So I'm going to hide the planes here, change the color, and inside here I'd also like to change the color like this, just so we can see. So those are the two connectors. I'm also going to save this, and I like to make those very simple, so to not make this video too long, but this applies to every kind of connector you have. You just need to study the connectors and have electrical knowledge and know how connectors work in order to electrify them correctly, and I show a lot of that knowledge in the courses. That's why I'm trying to show here how the software works, to see how simple the software is, but it's not about the software. So now let's make a new product. So this product is going to be the electrical harness number 1, and I would like to make another product, and let's name this the project file. So this is like a basic organization of files in a Catia V5 electrical. So those are not electrified yet. So as you can see, those are made in part design and assembly design, because this is how it starts, and the electrical workbenches are going to transform those files into electrical files. But first you need to organize them. Of course, you can make top-down construction, you can make bottom-up construction, you can be mixed. It doesn't even matter if you know what you're doing. I know that many courses, they have this approach to Catia V5, and I've been asked by students, how do you do top-down assembly, how do you do bottom-up assembly? It's just, I explained that in the courses, and it just does not matter how you do it as long as you know what you're doing. So in here, this is going to be the electrical harness. So I'm going to add the electrical components into the electrical harness file. So I'm going to add this here and this one here with copy paste. So this is basic Catia stuff. This is not something you should know this if you want to learn electrical harness. Otherwise you have to take my basic Catia V5 course. And then this product, I'm going to add it into the project file. So here there are all of them, and I'm going to close just this one. But first of all, I would like to save all of them, so I can save here, because this is the general file. Save management. I look here, what's saved, what's not saved. Save as, this is a new file. Save. Save. In the same folder. And the modified one, save. This is just open, it's not modified. And then click OK. So you can click again to verify. So now everything is saved. And of course you can also check the folder to see that the files are in there. So in here, depending how you construct the files and how you have the datum planes, when you copy paste them, they might come they will all come in the same position, but you can have like a design standard to have them all also in the right orientation. So that's also something that I teach in the course. It's a little too much to explain here. Maybe I'm going to make a separate video about it. Let me know in the comments if you understand what that is, and if you want a separate video. So those are the two connectors, and now I'm going to go to the individual files and electrify them first. So this is project file, electrical harness file. So I want to close this one because I don't need it. So the idea in here is that you need to make those files in such a way that they can be connected with a click, and also that we can connect wires So if I go into equipment and systems, electrical harness discipline here, and here we do electrical assembly design. Here on this toolbar, that is called electrical connection point definition, we have two buttons that are called connect electrical devices and disconnect electrical devices. So if I click on this one, the software says select the first electrical device to connect. The first device to be selected will be the one that moves. So if I select the electrical device and then I select the second one, they are going to connect between them, and the first one I click is going to be the one that is going to move to the other one. So now I cannot do that because those are not electrified. I'm going to proceed to the first connector A, and we are going to electrify this. First, you need to make sure that the file is saved and that all the mechanical modifications are made. Then with the connector open, we go equipment and systems, harness discipline, electrical part design. Okay, so this is the part design workbench equivalent to part design, but as an electrical workbench. So in part design, you build it from a mechanical point of view, from a solid point of view, and then when we switch to electrical part design, we give it electrical properties. So you see the buttons here change. So the idea is on the front of the connector, we want to give electrical properties that is going to connect this connector with its counterpart. And at the bottom here, or on the back side, we want to give electrical properties that are going to connect to a wire bundle or to a electrical wire. So let's start with this one. First, we need to define this part as a connector. And this is the toolbar where you can do that. So if you look here on all those buttons, I have here define connector. I click on this one and the software says select a part with no electrical behavior. So a part that is not electrified. I select this one. And I have some options here, single insert connector. We have other stuff here that I teach in the course, but part number, I'm just going to leave it like this. And number of terminations, it means the number of pins that the connector has, or terminations. If you're an electrical engineer, you should know what those are. Now I'm going to just put here 4 and click OK. So you want to make sure that you do not mess this up because you cannot modify those or delete them or something like that. You need a backup of the file, so you need to delete the file from the computer and restart with the backup. Some of them, they can be deleted or modified, but some of them, no. So this is another question that I get from time to time, even if I explain it very clearly in the course. So now you see that here it's like a small extra thing on this icon. So this means this is an electrical part of connector. So in fact it's the icon of the connector here. And now this one has electrical properties with 4 terminations. So those are important for other workbenches that connect with the diagram, the electrical diagram software. Now I would like to save this and switch to connector B here. Let's do the same. Let's define this as a connector. I'm going to click on this. Connector B needs to have the same number of terminations. If you do not have the same number of terminations, the software is going to tell you, because that does not make sense in reality. Click OK. I'm going to save this. So this is just the definition. Now if I switch back to connector A, so now I need to make the connector connection point. So this is the point. So this is what the software is going to use to connect this with its counterpart. And in here we have different connection points. This one is defined connector connection point. So if I click on it, it says select a single connector, a multi-connector, or a connector connection point. So if I click on this one, because this is defined as a connector, we have here connector connection point 1. This is the automatic name that I'm not going to change. We have representation, contact, coincidence, and orientation. And those are placement constraints. They work like the constraints in assembly design. So the representation is going to be the face where I want this connection point to be annotated in 3D. So I'm going to choose this side, because on the other side maybe I have another type of connection point. So I'm going to choose this surface. Then the contact is going to be the head of the connector, that basically when you push it into its counterpart, the contact is going to be a surface that stops the connector from being pushed forward. So it can be the face of the connector, or it can have like an edge. In this case we do not have an edge. We can design one, but I'm going to choose the same surface, the head of the connector. This is going to stop the connector from being pushed forward. Coincidence is going to be the coincidence to align the connector into its counterpart hole. So in this case, it's going to be the central axis because this is cylindrical. So in here, the software, it's automatically selecting the central axis. So I'm going to click on that. And the orientation, it's going to be a plane or an axis that is going to tell the software how to rotate the connector inside its counterpart. So this can be based on pins, or it can be based on a Poka-yoke key that the connector has. So again, if you don't know what a key is or a Poka-yoke key is, that's just electrical knowledge about connectors that I also explain in the courses. So in here, I'm going to use one of those pins because it's convenient as orientation. So I'm going to use this one here and click OK. So now we have all the elements that the software is going to use to position the connector accordingly. One last thing that I want here is to check those pins. So it's 8 from the center with 4. So in here I would like to do the same thing on this surface. So I'm going to go to part design, position a sketch here. In here I'm going to position a circle, the diameter of 4, and I want to make this at 8 millimeters from the horizontal axis. So the holes for the pins in the connector are 30 millimeters. And I'm going to make this those ones shorter. I'm going to make this one 20 millimeters. It's enough just for this demonstration. And then circular pattern, 90 millimeters. 4 instances. Click OK. So those are the pins. And we are going to make here the same electrification. So if I go into Equipment and Systems, Electrical Harness Discipline, Electrical Part Design. So this is already defined as a connector with 4 terminations. I only need to define connector connection point. Click on this, click on this. Representation. For a representation, I'm going to use, I can use this external surface or I can use this internal surface here. So let's use this one here on the interior just to show where the actual connection point is. Contact is going to be this surface that gets in contact with the surface from the counterpart. So the physical surfaces I'm referring to. The coincidence is going to be the same axis that are going to get into coincidence from the connector and the counterpart. So it's going to be the axis of this hole. And the orientation, I have to use one of those pins and it has to be the exact same pin as the connector counterpart. So in this case, let's say this is the pin. I'm going to click OK. So now let's save this. I'm also going to save this one. And if I go into the project file here, and here I want to activate the product where the electrical components are inside. So this is going to be the electrical harness. I want to make sure that this is active. So this is basic Catia V5 stuff. And if I use those buttons that we were discussing at the beginning of the video, connecting electrical devices, if I click on it, and if I hover only on this connector, and now you see that the software is going to allow me to select this. So if I select this one, now the software says select the second electrical device to connect or directly a connection point. So in here, only if I hover, it's going to show me the connector connection points. So you see, this is the representation that we selected, is this surface in here, where it's annotating the number, the name of the connector point, and here the same. So now, if I click, so I need to click on that specific place, closer to that. So if I click here, this connector is going to go right there. So let's see if it's correct. So it's automatically creating here some constraints. And in here you're going to see this those constraints that are automatically created. So I would like to hide those because I don't want to see them. And now let's see if the connection is, the mechanical connection is correct here. So first time when you electrify connectors and you connect them, you want to verify this, to go into assembly design and to use the sectioning tool to see how the connection is, if it's everything okay. So in here, I want to take a close look. I see the pin inside. That's great. The other two pins and the third pin. So this is great. And now I can kind of rotate this to look around the connector. I want to make sure that it's all good here. So everything is aligned. Also here. So you can see the pins are where they are supposed to be. Let's also see from above. So everything is correct here. And another thing that you can do in here, so this is not necessarily important, but you can actually assign an element to each termination, a representation. So let's say for this one, it can be this surface or this surface here at the end. Usually it should be the surface that has the electrical contact, the metallic surface of the pin. So if this is the termination number 1, just double click on it. We have the name here. You can change the name. You can write pin 1 or whatever other name this pin might have. And the termination, I can just select this surface, this face. So when I click on it, it's going to show me what that pin is, pin number 1, 2, 3, 4, 5. So it would be correct to do that. So on the 3D model, you know which is pin 1 and which is pin 20, or maybe you have 50 pins. Who knows how many pins you have on that connector. So let's save this. I'm going to close this. Go and also to close the connector B. And I'm going to save the file. So I'm going to save all of those and close them. And in the part 2 of this video, we are going to see how we create the other electrical point, which is for the wire, and how we connect wires and how we can play around with that wire and maybe do a small wire routing on a path. So there is nothing to download on this video. That's why I did those connectors very simple, so you can also make them with your own software. If you also did those and everything I showed in this video as an exercise, just save them and keep them in your computer, and you can use them on the part 2 of this video. So see you in the next video.